In this video, we're going to determine if piecewise functions are differentiable. So I'm just going to have a couple problems. I'm going to have 3 problems in this video. And we're going to show you the 2 simple steps in order to tell if a function is differentiable. So the first thing you want to test is continuity. Why? Well, if a function is not continuous, then it's not differentiable, and you don't have to waste your time doing the second step. So first step, test continuity. Well, in order to test continuity, we need to see if the 2 functions in this case reside at the same point at x equals 1. So this is where the piecewise function sort of separates these 2 functions. So we need to write down x squared, and we need to plug in 1 into x squared. And we also need to plug in 1 into 2x minus 1. So we just at the intersecting point between these 2 functions is x equals 1. So we plug in 1 into those cases. If we plug in 1, you get 1 squared, which is just 1. If you plug in 1 here, then you get 2 minus 1, which is equal to 1. So the function is continuous in this case, since they have the same y values at the same x values. All right, let's test for differentiability now. Now this is where differentiability. This is where it gets a little difficult, but all you need to do is find the derivative of both functions residing in the cross between the 2 functions. So at x equals 1 is the place where both of these functions change, and just find the derivative. So the derivative, I need to fix this 2, I need to fix the 2. I don't know why I undid everything. Okay, dx, dx. Okay, 2x minus 1. The derivative of 2x is x squared, sorry, is 2x, and the derivative of 2x minus 1 is just 2. Well, that means the derivative at every single point is 2 on this function right here. And we need to test if the derivatives of both the functions are equal to each other at their intersecting point, which is x equals 1. So we need to plug in 1 into this function. If we plug in 1, we get 2. We get 2. So both the derivatives are equal to 2, and they're the same. Therefore, this piecewise function is differentiable across across infinities, basically. All right, for the next problem, again, we test continuity first. Continuity. So what is the intersecting x value? The intersecting x value is at 2. So we just plug in 2 for both of the functions, 4x minus 4 and x squared. If you plug in 2, you get 2 squared, which is 4. If you plug in 2 here, you get 8 minus 4, which is equal to 4. So continuity, the same. Both the function values at 2 are the same, 4 and 4. All right, now we test their derivatives. So differentiability. Wait, did I spell it wrong in the last? I spelled it wrong in the last problem. dx for both of the functions. So x squared, 4x minus 4. Power rule gives us 2x here, and power rule gives us 4 here. So at x equals 2, are these 2 functions differentiable? Do they have the same derivatives? Therefore, there's no sharp turns. Do they have the same derivatives? So let's check it out. At x equals 2, well, the derivatives are always 4 on this line, but let's check out 2 in this case. So you plug in 2 for your derivative function for x squared, you get 4. Therefore, both of their derivatives are 4 at x equals 2. So this function is differentiable across infinity. So we're checking to see if this function is not differentiable. First thing we always check is continuity, right? Continuity. If a function is not continuous, then it's not differentiable. So continuity, let's find the intersecting point. Both these functions change at x equals 3, so we just plug in 3 for both of the functions, x squared and the absolute value of x minus 3. You plug in 3 here, you get 3 squared, which is 9. You plug in 3 here, you get the absolute value of 0, which is just 0. Therefore, it is not continuous, and this function is not differentiable at x equals 3. So genuinely, it's if you check for continuity and there is no continuity, that you could just skip the last part. Don't worry about it. That's why you check for continuity first. That's why you don't check to see if their derivatives are the same first. Let's see if this function is continuous. So let's check for continuity first. I keep spelling that wrong. Continuity. And the intersecting point is x equals 0. So we plug in 0 to both of the functions. So 0 into x and 0 into x squared are both equal to 0. Therefore, this function is continuous. But we haven't checked for differentiability yet. So let's check for differentiability. Alright. So let's find the derivatives of both of these functions. So the derivative of x is equal to 1. And the derivative of x squared is equal to 2x. So let's plug in 0 into both of these. So if you plug in 0 into 1, you still get 1. So the derivative is just 1 for your function x, no matter where you go. But if you plug in 0, let's change the color. If you plug in 0 into 2x, you get, well, 0 times 2 is just 0. So therefore, the derivatives are not the same at their intersecting point. Therefore, this function is not differentiable at x equals 0. So, as you can tell, the steps for this are not that bad. You just need to check for continuity first. And then once you check for continuity, you just need to check for differentiability. Differentiability. Now, keep in mind, continuity does not guarantee differentiability, but differentiability guarantees continuity. So if a function is continuous, it does not have to be differentiable. But if a function is differentiable, then it must be continuous. So basically, if you check for continuity and it is not continuous, then your differentiability also has to not exist. So just check for the continuity and differentiability in that order, and you can save a lot of time rather than checking within the other way. So, but as always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.